Hey guys, Fru here. Thanks for joining me on my channel today. So before we get started, we're gonna get the hourglass flipped over. All right, so there we have it. Guys, thanks for joining. Today we're gonna be talking about data science. Data science is one of the hottest things there is in tech, from a career perspective, from a payment perspective, from the types of problem they solve. Is very fascinating and it's really hard. So it's no surprise that a lot of people are very excited about this. A lot of people are looking to get into data science. A lot of people are looking to make that career switch into data science, or just to grow long term and succeed into the field of data science. So I'm guessing that because you clicked on this video, that's you probably heard about data science and you're interested in getting in. But how do you do it? How exactly do you go from zero to being a data science hero? And guys, that's what we're going to talk about here today. A little bit about my background. I've been doing Hadoop for quite a while now, I would say, starting around 2013 to 2014. Worked at a company, implemented some Hadoop applications, brought it into productions, and now really switching into machine learning and AI, which is really my interest. I do a lot of architecture work, and in my role as a pre-sales engineer, or as a solutions engineer, or a sales engineer, I get to work with a lot of customers and a lot of companies that are looking to transform their data journey. And being on the front lines, I get to see companies and the need that they have for data transformations, and ultimately data scientists to come in and to help them. So guys, I'm going to draw from all those experiences and really talk about to address the question that we have here today, which is, what are the things you need to learn if you want to get into data science? So what are the steps if you want to learn, if you want to get into data science? So a lot of organizations, or a lot of teams, or politicians, or countries always have an agenda, right? If you want to read a book, there's always a table of content that tells you what's in that book. It guides you. Companies would always have the agenda. They will always have their objectives that they want to meet. It's almost like their game plan. Teams or sports teams, NBA, NFL, or wherever you watch sports, would always have a game plan when they're going in to meet an opponent. And what the game plan does is, it tells them what they hope to achieve, how they would play and attack the opponent, and how they will react if the opponent attacks in a certain way. So when having a game plan, it doesn't mean that everything that you have in your plan will go according to plan, but it just simply means that you have a guiding principle, a strategy that can help you succeed. So game plans are very essential for sports teams, for companies, for countries, for very successful individuals. They all have game plans. So guys, the reason why I brought that up is because there is this quote. I can't quite attribute that quote, but I might leave it below, that says, not every battle is won according to plan. Not every battle is won according to plan. But that quote, which I love so much, guys, it says, not every battle, or not any battle, has ever been won without a plan. So let me say it again. Not every battle is won according to plan, but no battle has ever been won without a plan. So if you're going and thinking about getting into data science, it's very important to step back and to ask that question: what is your plan? How do you plan to tackle this? Not just to get in, but to make a successful career out of it. Do you have one? Maybe you don't, guys. And that's why I want to talk about the 5 steps, the 5 points, the game plan that you can execute on and position yourself for great success in data science. And a lot of these items I'll talk about in the plan came from a book that I wrote about data science, or machine learning, or data analytics. It gives you that foundational skills if you want to work with data in general. What are the things you should be learning and having on your resume in order to get into the field and to succeed? So I'm going to leave a link to the book below for those of you who want to check it out. Grab it from Amazon. It's a very easy read. You can finish it in a night or 2, and it will help you very much. The book also has tons and tons of resources to help you along the way succeed on your journey to being a data professional, data science, data analytics, big data, machine learning, AI, wherever you want to go. You want to have the solid foundation and the game plan you can follow, so that once you get into that battle, you can execute and be miles ahead of the competition of the market. So guys, what is the first thing in that plan that I would focus on to get into data science? Like I said, there are 5 things, and so we're going to cover them one by one, and this is in no chronological order. And believe it or not, some of the things I would say, or some of the items I have listed here, will surprise some of my viewers. But I'll be curious, if something surprises you, don't hesitate to go down into the comment section below and leave your thoughts. I really want to hear what you guys think. And if there are any success stories from this, whenever you're watching this, guys, always make sure you come back and leave them in the comment section below, and I will be more than happy to read those and to discuss with you on them, guys. So going in, the number 1 thing that I want to learn, the very first thing, or the paramount thing that you really want to have in your tool belt, is some form of spreadsheet. Now, we know Excel is the most popular spreadsheet there is out there, so I would spend some time and I will learn it. So listing this as part of the game plan doesn't mean you go out and take a course on spreadsheet. Or some of you might watch and say, but why would you say learn Excel? That's so trivial, right? It's basic stuff. Why will I ever learn Excel as part of my game plan for succeeding in data science, data analytics, or any of the data fields? Now, if that's your thinking, let me explain. There are a lot of statistics that have been put out there, but if you look at most of them, Excel usually ranks among the top 5, if not top 3, or top analytical platform that is used within organizations. So a lot of people are using Excel. And why are they using Excel? Because a lot of companies use Microsoft and Microsoft Office, and guess what? Excel is part of Microsoft Office. So, and it's very easy to use. What is the first thing that people do? You give them some form of a data set for them to do a quick manipulation. What do? Do they go out and spin up an IDE to start doing some Python queries and manipulation on that data set? Or depending on what the task is, they can quickly pull that into Excel, do some summarizations, do some pivoting, format it, put some good bar graphs, and send out the report. Guys, so a lot of people, bottom line, are using Excel as a data analytics tool. And if you're trying to get into that field, it's very important that you have Excel. If you haven't been exposed to Excel, you want to spend some time and expose yourself to Excel. Not just the basic features of Excel, but some of the more sophisticated features of Excel, functions, and creating your own defined functions and variables, and just getting a little bit more advanced with using Excel. That will help you in the long term. Now, before we leave the Excel topic, I know that for those that are enterprise architects, or for those that are security folks, or for those that are used to enterprise type scenarios, would always want to smash Excel down and say no one should be using Excel within the organization. I understand that. I have an enterprise architecture background, and there is a need for lockdown for security and control, because Excel comes with a lot of problems if you use it as your enterprise analytical tool. And what are some of those problems? Data redundancies, right? Many people having different versions of Excel. Who has a single source of truth? No one really knows. There is security. There's really not a lot of security around Excel files. You can just take a file and send it to somebody and data moves around. So Excel comes with a lot of challenges. What if the file gets corrupted? You've lost some calculations, or you've lost some data. So that could be a drawback for Excel. But despite all those drawbacks, we just have to be aware of the fact that a lot of people, as their first or second instinct, when they have, depending on the size of the data they're working with, they pull that into Excel, and that's what they use for analytics. And guys, and if you're gonna get in there, you better be using Excel, or be aware and familiar with Excel, so you don't embarrass yourself someday. Imagine your boss comes to you, you have a certification in machine learning and AI and Python and master's degree in B, and they just have a small data set that they need to analyze very quickly and do some calculations so that they can send it out on a report. And you're there scratching your head and no idea, and he says, why don't you just do it in Excel? And you realize that, I have no idea. I've never used Excel before. It's so basic. guys, you will look stupid doing that, right? You look incompetent if you put yourself in that position. Again, it doesn't mean that it should be your go-to tool. It just means that it's so basic that you want to cover that base. You want to cover that base so that if it ever comes to you, it's not even a question, you can do it. So game plan number 1, I would get familiar with Excel, really familiar with Excel. Guys, now we'll go into the next piece. What is game plan number 2? Well, Excel, once it starts reaching its limitation, then we start thinking about a database, a relational database. So as game plan number 2, you want to be familiar with relational databases and what comes with it, SQL. This is so important that you will not even believe. I can't tell you how many people I know that say they are a quote-unquote big data professional, or they are quote-unquote AI professionals, or data science professionals, whatever you choose to call that, and they are so used to advanced stuff that to them, why would you write SQL? But guys, if somebody tells me that, I just know that this person doesn't really know a lot of what they're talking about, because SQL is so pervasive, you cannot run away from it. Now, the argument that people use when they talk about being big data professionals is because they go with the thinking that big data means you can work with unstructured data, and so if you're working with unstructured data, there's no need for SQL, which is structured query language. But that's just very misleading, because ultimately human beings do not consume unstructured data. We just don't. We consume structured data. So whatever data you're working with, it could be log files, or it could be clickstream, it could be whatever data in any unstructured format. Ultimately, when that gets consumed, somebody translates that into, summarizes it, or cleans it up, or gets it structured into a structured format of rows and columns that people can summarize and put in nice charts. And there you have it, structured query language. And SQL, you just cannot escape from it. So if you want to get into data science, I'll pay special attention into understanding relational databases and SQL. There are a lot of relational databases out there. Oracle, Teradata, Netezza, MySQL, Postgres. There are just so many flavors you can't even begin to count on your fingers. You're gonna run out of fingers pretty quickly. Big vendors, small vendors, paid, open source, it doesn't matter. Pick one, understand the concepts of it, and be able to write basic to advanced SQL queries. DMLs, data modification languages, DDL, data definition languages. Be able to just understand how they work, select statements, updates, all those things, joins, inner joins, outer joins. You should be able to understand that, right? Just because you're a big data engineer, it doesn't say, well, you should have no understanding of doing a simple join across two tables. Even in the big data world, you have things like Hive, Impala, which are all SQL based constructs or SQL based platforms. So SQL is something you just cannot escape. And relational databases, the theory of what it is and how useful it is, you just cannot escape it on your journey to being a successful big data professional. Now, we've talked about Excel, we've talked about SQL and relational databases. Guys, what is game plan number 3? And that's what I'm going to talk about right now. So guys, game plan number 3 of what I'll pay attention to would be ETL, extract, transform, load, or the new flavor of it, which is called ELT, extract, load, and transform. I would make sure I understand that. All of that, ETL or ELT, falls under the category, in this case, of data integration. So how is data moved from one source, how is it transformed, and how does it get to the destination? There are different patterns that apply for data integration. There is batch processing, there is streaming processing, real time. You want to understand that, have an understanding. There are ETL tools, there are ETL methodologies. There are tools like Talent, Informatica, Ab Initio, a lot of them. How can you connect to all these relational databases or unstructured databases or websites or APIs? How do you grab that data? How can you transform that data in flight and then put the data somewhere where you can consume, either in a big data environment like Hadoop, and HDFS, or in more cloud types of applications like S3 and Redshift, Snowflake, or Oracle, you name it. But you don't have to go out and be an ETL expert. I'm not saying that go out and get every certification on ETL there is. No, far from it. Guys, what I'm simply saying is just have some foundational skills and understanding of ETL and that entire process. Because as a data scientist, let's assume for a second that your job as a data scientist is to work with the end data, and that's all you care about. There are some people that's just what they want to do. Give me the data in an HDFS directory, and I'm going to use all my Python whiz and work with that data. I'm not an ETL developer. Sure, I understand that if that's your argument. But guys, I always say you don't want to be a one-trick pony. Depending on the organization that you work with, what if the data you're supposed to work with doesn't show up? Do you know how to articulate that to the ETL developer, or can you go out yourself and get it? If you're working on a project and you're missing a dimension data to use for your queries and for your machine learning model or for your data science project, can you go out and do a little bit of gimmick to get that data in? Part of that is ETL. So having some foundational skills on ETL would be very, very, very powerful. You cannot escape that. I will highly recommend it. Again, like I said, tools like Talend, some of them are open source. You can just get it in, understand how to connect to different data sources, relational databases, ODBC, JDBC, flat files, tab delimited files, XML, JSON. How can you connect to sources and pull that in? APIs as well. How can you connect to those different sources? If I say go to Twitter, use the Twitter API, grab data and bring it to me real time so we can analyze it. Can you do that? Or do you have an understanding of how to even go about doing that? You can do it in code and writing Python code, but like I said, there are a lot of tools that are dedicated to just ETL, like Talend and Informatica and DataStage, a lot of them out there. So just having an understanding, if you learn one, you can always translate your knowledge across multiple of them. But I will spend some time, pick an ETL tool, learn it and understand the concepts of transformations, validations, structuring data, data quality, and all of that. So very important as point number 3 in the game plan. Now guys, so let me summarize what we've discussed. Point number 1, we've talked about Excel. Point number 2, we've talked about relational databases and SQL. Point number 3, we've taken it to the next level to talk about ETL. So you see where we're going? Excel, small, SQL and relational databases are better than Excel. Well, if you have your databases, how do we get data into that database? Now we're talking about number 3, which is ETL and ALT. Point number 4, and this will be, I'm sure this is what a lot of you came here to watch, for me to talk about, and that is learning some form of a programming language. There are so many options out there, but the tool that people always talk about is Python versus Java for data science. I've made a video on this already, and if you go on my library somewhere, you would find that video where I talk about what should you learn, Python or Java, especially for machine learning. People tend to ask that question a lot. Java is used in the enterprise a lot. Python really has a lot of libraries that are great for machine learning. So if your only focus is machine learning, sure, go ahead and learn Python. NumPy, Pandas library, Matplotlib. There are so many libraries in Python that makes it a lot great and amazing for data science and machine learning. So you maybe want to start with that. There's also that you can do a lot of the things in Java, but to be honest, Python seems to win the day here. Now, would that be true forever? I don't know, but based on what I know now and what the industry is doing now, Python is very amazing. Now, there is a third piece, which is Scala. A lot of people might be choosing between Scala and Python, and the question is, which wins, right? Scala or Python? That's a debate between the functional programming language and all the debate that goes on there. I might make a separate video on it, but just pick one programming language and learn. And why should you learn a programming language? Because a lot of machine learning or data science needs for you to build models, and you can't build that model in Excel. You cannot build the model in SQL, and so programming languages are what you use to build it. So pick a language and learn it. And to be honest, once you learn one language, you can easily pick up other languages, because the concepts of programming itself doesn't change. Variables, conditionals, those are pretty standard across languages. Now the syntax might change from one language to another, but if you understand the foundational concepts, you can always pick it up and use it. And today with Google, anyone can reference a syntax. If, say, you want to program in Scala, how do you do loops in Scala, or how do you do conditionals in Scala? Then it becomes a thing for syntax than a foundational thing of can you program. And programming also helps with automation. You might want to automate things. If a file comes here, pick it up, run the scripts, validate it, structure it this way, run this model and put it down. So programming skill is something that you need to have. You cannot get away with really calling yourself a true data scientist without knowing some program. Like I said, start with Python. There are a lot of resources you can use to get started with Python. So just pick that, get started, and get familiar with it, and that will really help you in your journey. Now guys, we've talked about 4 things. Like I said, this doesn't have to be in chronological order. It doesn't have to be you have to do A, B, C, D, or like Excel, SQL, and ETL, and then programming. You can always mix and flavor them up. Excel can take you a day or two. You get a refresher on Excel and you're great. And then you know SQL and you keep building up your SQL. And then ETL, you learn one tool and then you learn another tool and then you really build your competency in ETL. And then same too with programming. You might want to start off as a novice and write 1 or 2 scripts. And as you get familiar, you can even take certifications if you want and then build all your programming skill. And this takes us to point number 5, which I think, guys, if you took anything away from this video that I'm making, is on point number 5, and that is you have to continue to adapt and be ready to change, because everything that I've said here in the first 4 points might be irrelevant in the next 2 years. Guys, that might be irrelevant. Maybe Excel, that's not very likely, but Excel could totally disappear, right? SQL could be replaced by something else. We know about NoSQL, which doesn't replace SQL, of course, because it's not only SQL, but maybe that's what you should be paying attention to, right? With AI coming into the mix, a lot of things are changing and no one really knows what the future holds, right? So regardless of what you take from this thing, guys, is that you always have to stay on your toe and be ready to adapt. Be curious, look for new technologies, learn new things. Do not get stuck in one way of thinking, because especially with data science and machine learning and AI and some of those things are changing every 6 months. A new library is coming out, a new way of doing something is coming out, right? Deep neural networks are coming out. So you always have to stay on your toes. And if you have these 5 things, guys, it really allows you to get into an organization and feel comfortable from end to end, because you can work with the small data and do your quick massaging and data wrangling, all the way to understanding SQL and talking with SQL folks and answering business questions and being able to do ELT and get data you want, or give data to somebody that you want, write scripts and programs to be able to transform data the way you want. And then also finally, guys, be able to adapt, because if things are changing, you want to be able to respond to it as well. So the 5 points that you can follow to not just get into the field, but to make sure that you're successful long term, guys. So all those 5 points that I discussed, I elaborated in more details in my book. Again, like I said, I'm going to leave the link below for those of you who want to get it from Amazon. It's available on Amazon for you to get. So check it out from Amazon. Your game plan, this is really a game plan, your 5-point game plans. And in this book, what I really did was I broke it all down, and I also provided a lot of resources. So if you want to get into Excel, what kind of resources are available for you to use? Same with ETL, same with SQL, same with databases. There are tons and tons of resources that are available for you to get started, so that you can build your competency, go out and apply for the jobs that you need. I hope this helps, guys. If this helps you, be sure to go down in the description and leave a comment. I really want to hear from you guys. Does this game plan resonate with you? Do you have a game plan? Have you heard of other game plans, guys? So make sure you discuss in the comment section below and leave all feedbacks. I'll be reading those feedbacks and responding to them as well. And I also want to thank you for watching, and be sure to subscribe to this channel if you haven't. and I'll talk to you next time.